Hey everyone, Mrs. Slauson again, still at home, still might hear barking dogs, so just a heads up. Alright, we are moving on to 1.2 in our notes, and this is going to be a section, not that the other section wasn't, but we are going to be using this section all throughout Algebra 2. Alright, so here we go. So what we're going to be doing is interpreting graphs, describing graphs mathematically and also verbally. And you had a little bit of this in Algebra 1, but not as much as we're about to hit in Algebra 2. So we're going to be learning about interval notation, which we did talk about in class when we talked about that whole temperature in the Sahara Desert. And we're going to learn how you describe a graph through increasing, decreasing, positive, and negative. There's the relative max and min. We're going to talk about something called end behavior. Average rate of change, which you are familiar with, is just another word for slope. Domain, range, evaluate, solve, and again, we've already talked a little bit about evaluating and solving. So a couple things to note, that when you see this symbol, that this means greater than, and this should be cut out. This is, oh sorry, never mind, I'm not even reading the directions. We are going to match the following. So we got our different symbols here. This is our less than and this is our greater than. I remember that this is a less than because this looks more like a capital L than this one does. So this one is less than. This then is greater than. When you put the little underlining under there, that is less than or equal to, which I realize we have this twice, so there's a little typo. We'll make that one less than or equal to, and that's going to make this one greater than or equal to. The closed dot is going to attach to the equal to part. And when you see an open circle, that's going to attach to just the regular less than or greater than. Okay? So let's first talk a little bit more about interval notation. So this is inequality notation, and you use this in middle school and freshman year. And now in Algebra 2, we're going to move on to interval notation. So a big thing is we're going to be using parentheses and brackets. So we're going to be using brackets when it includes the value, and we're going to be using parentheses when it doesn't include the value, which means we can get really close to that number, but it's not going to quite get there, okay? So when we read this, it's always best to have the variable on the left side because we read from left to right. So when we talk about math, we also want to use it left to right. So I would see this as x, or all the variables I'm looking for are going to be greater than 2. So just a reminder on a number line, I always like to have like a reference point of 0, then this would be 2. And with greater than, you use the open circle, and then I want all of the numbers bigger than 2, which would be going to the right. So the other reason why you want to have x first or on the left side is because if this is first or on the left side, then whichever way the inequality sign points is the way it would point on a number line. All right, so let's just take a look at this one. Then we're going to talk about interval notation. So first, it's better to switch it. So since I'm switching everything around, I'm going to switch this around. And this is saying all my values that are less than or equal to -4 or smaller than -4. So again, I like my reference point of 0, 1, 2, 3, 4. And this time it's going to include the value, so I'd put a closed circle. And then anything, whoops, sorry, here, not there. Let's see, I do have some white out. Don't need that. But, it's, oh no, there we go. My mistake. Anything smaller than and including -4. And then the other one, I lied, we're actually going to do this one, is when you see this symbol, x in the middle, and it's always with less than signs, it might be less than or equal to, this means between. So all the values between 3, including 3, all the way up to 7, but you're not going to include 7. So let's say here's 0, here's 1, 2, 3. I'll make a closed circle because it's the equal to part. 4, 5, 6, 7. I'll make an open circle because we're not including 7, and anything in between. And then the final scenario is you're going to have where x is greater than 7 and or and x is less than or equal to 2. So here, let's say here's 0, here's 2, 3, 4, 5, 6, 7. So with 7, I'd have an open circle, and it's greater than, and it's also pointing to the right, and less than or equal to, so a closed circle, and it's pointing to the left. So in Algebra 2 and in Algebra 1, we're either going to just have one inequality, you know, it'll go, where's my hand? It'll go this way, or it'll go this way, or we might have two inequalities, and that means they're either going to both go out or they're both going to go in. That's at least for Algebra 2. So let's talk about interval notation. So when something goes on and on and on, like it is in these two cases, that means it's never going to hit an end. And so what we like to use for numbers that never end is the infinity symbol. So when it's going to the right, we're going to use a regular infinity sign, and when it's going to the left, we're going to use a negative infinity sign. So basically what's going to happen when you do interval notation, you're going to have something here, a comma, and something here. And then surrounding it, you're going to have either parentheses or brackets. So first of all, what I like to do is put my numbers or possibly infinity signs in here. So when I say 2 and getting bigger and bigger and bigger, that means it's going to infinity. So the first number is the smallest of the two values, and the right side is the bigger of the two values. So I'm going to put 2 because that is smaller than infinity. And now either I'm going to put parentheses, which means I'm not including the value, or brackets because I am including the value. And see how this is an open circle? I didn't want to include 2. I'm going to use this. And then with parentheses, with an infinity sign, you always use parentheses, because if you know, you can never reach the end, so it's never going to include infinity, so you're going to have parentheses every single time with an infinity sign. So these are saying the same thing. Anything bigger than 2, don't include 2. Anything bigger than 2, don't include 2. Anything bigger than 2, but don't include 2. So in this one, we're going to look at anything smaller than -4, all the numbers smaller than -4. So since it's going this way, you know, we got that negative infinity sign here. So if the smaller is here and the bigger is here, negative infinity is as small as it can get, and -4 is all that we're going up to. And since I have this closed circle, or the underlining here, I use the bracket to signify that I'm including -4. And again, always with infinity, we're going to use parentheses, because if you put it here, I mean, you can't include infinity because it keeps going forever and ever. All right, so when you have something like this that's between, then again, one number here, something here, smallest on the left, biggest on the right. I actually just have two numbers. The smallest number is 3. The biggest number is 7. Because of the closed dot or the underline, I should include 3. And because of the not underlined and not closed, I should use parentheses. So this is saying all my numbers are between 3 and 7. I'll include 3, but it's close to 7, but it's never going to be 7. All right, when you have 2, this is probably the toughest one, and I think it's easier to show on the number line. So again, it's 2 and anything smaller than 2, on and on and on. So I have a negative infinity, but then I have a whole separate, another arrow. And it's 7, and it keeps getting bigger and bigger. Well, it doesn't include 7. And when it keeps getting bigger and bigger, I have the infinity sign. So I'm actually going to have 2 of these. One for the 2 stuff, and then one for the 7 stuff. And again, looking at this one, smallest on the left, biggest on the right. The smallest is negative infinity. Remember, this 0 is just a reference point, and 2 is the biggest. Because of this, I include the 2, and always parentheses with infinity. And when I look at this one, smallest on the left, that's 7, biggest on the right, that's infinity. I don't want to include 7, so I put parentheses, and always parentheses with the infinity. And when you have 2 of them, we like to put this in there, because we're talking about this one and we're talking about this one. So it looks like a U. All right, so just how do you read this? So this is anything in between 2 and 8, including 2 but not including 8. So again, let's say this was 0. Here's 2, 3, 4, 5, 6, 7, 8. The 2 I should include, The 8 I should not include because of the parentheses and anything in between. And then in this one, I'm saying anything, going smaller than 7 and including 7. So if this is 0, 1, 2, 3, 4, 5, 6, 7. So if negative infinity then is over here, I'll include 7, but then it'll just keep going and it'll never end because we're going to infinity. How do I write this? Well, again, between in an inequality looks like this. So it should be between 2 and 8, 2 and 8, and include 2. And this is saying all my values are going to be smaller than 7. So all the values will be smaller, including 7. So there's inequality versus a number line versus interval notation, and we will be using this. Okay? Probably the biggest mistake we see here is the not placing of the parentheses versus brackets correctly. All right, let's move on. So let's start talking about the stuff. So you saw average rate of change already. That is, again, average rate of change. These are all vocab words here. It's just another word for slope. Slope is a steady increase, a constant rise over run. And what we do in a shape that's like this is we just kind of average out that slope. Because, if I rise 3, run over 1, rise 5, and over 1, those are different slopes. So I'm just going to kind of find the average between those two. That's why it's called average. And then rate of change, that is slope. So rate of change is slope, but we're going to average. So instead of this curve, we're going to look at it, instead of this curve, we're going to look at a more steady increase. So you already know slope, although this seems to be one that every year we forget. This means change delta y over delta x. It just means you subtract your y's over your x's. And now when you see this, we're used to seeing an ordered pair, but this is interval notation, and these are the x values. So I will give you the x values, and you will have to somehow figure out the y values. So for instance, if x is 1, then if x is 1, I got the y value of 1. And if x is 3, I got the y value of 9. So these will be my y and x values that I'm going to use when I use my average rate of change or slope formula. So on top, I'll subtract my y, so I could do 1 minus 9 or 9 minus 1. I'll do 9 minus 1. And since I did 9 minus 1, I have to follow that same direction. That's what these little 2's and 1's mean. I'll have to do 3 minus 1. It's not whatever is easiest to subtract. Whichever way you subtract one set, you have to subtract the other. So when we're done, we get 8 over 2, and that means on average, there's a slope of up 4, rise, and run over 1. So if I were to get from here to here, I should be able to just take the path in the end, this point to this point. I should be able, instead of doing these, over 1, up 3, over 1, up 5, I should be able to average that up. So I'm going to rise 4, 1, 2, 3, 4 over 1, and then I should be able to do again 1, 2, 3, 4 over 1. All right? So we're basically kind of finding that straight line between them. All right, increasing. So increasing is when you look at a graph, we're always going to read it left to right. So increasing, I'm going to use orange, is we're looking at where the y values increase, all right, as the x values increase. So the x values increasing ensures that we're reading left to right, but we want to look at where the y values increasing. So some people might look at this arrow and say it's going down, but when we look left to right, it's increasing, okay? And then let me just go ahead and do decreasing at the same time, and then decreasing. So now all the y values are decreasing until I get to the bottom, and then they're increasing again. So it's always left to right. And when we do this, we're going to use the x values. Even though we're describing what y is doing, it's always the x values, because remember, we're working with functions. And whether the function is just a regular function or a one-to-one function, the x's never repeat, all right? And sometimes the y's can repeat. It just, again, that depends, is it a function or a one-to-one function. So we always want to use the x value numbers when we do our interval notation, because if x never repeats, I'm not going to have the same number here as I do here. And I'll show you an example of that when we get down to these two. All right, so I'm going to do my increasing. If you notice, I have two increasing, so I'll go ahead and put, well, I should have spaced that better. Sorry, bad eraser. So here's one increase, here's the other increase. And then I have one decreasing. So again, I'm just setting up interval notation, smallest on the left, biggest on the right. So what I need to do is always mark these important points. So we will mark any x-intercept, any end points, and any turning points. So let's just start with the end points. What I mean by the end points are these arrows. So in the end, what's this arrow saying? Well, in the end, this arrow is going to the left. So as it goes to the left, that means my x's are getting smaller. But this arrow also indicates that it's going down, and down means that my y's are getting smaller. So I'm going to write these as an ordered pair, but with infinity symbols. This arrow is saying, you know, it's going to the right, so right means the x's are getting bigger. But this arrow is also going up, so the y's are getting bigger. The other thing we want to mark are our turning points. So this is a turning point, and this is a turning point. And for this one, I'm just going to estimate what these are. So I think this point is 1, 2, let's say over 3 and up 1, 2, 2.5. So that's this point. And this point, we're going to say it's over maybe, let's just go for 1, because it's close to 1. And then it's down 2.5. So again, those are greatly averaged out. The other thing you want to mark are your x-intercepts. So I think this point is 1, 2, 3, 4. So -4, 0. X-intercepts always have x being a value and y being 0. And this one is 2, 0. Again, an x-intercept has x as a number and y as 0 every time. All right, so what I'm going to do is I will be putting the smallest x-coordinate here, the biggest x-coordinate here. Smallest, biggest, smallest, biggest. All right, so I'm going to start with my increasing. What I like to do is not just do all the increasing. I go increasing, then decreasing, then back to increasing. So when I look at this stretch, what I want to talk about, as the y's are getting bigger, what are the x values that are describing that? So it starts at -infinity, and it goes all the way till it hits the top of -3. And then I've got a decreasing. I'll get to the parentheses and brackets in a moment. So in decreasing, I'm looking where the y's are decreasing, but I'm going to use the x values again. Always use the x values because you want a clear start and a clear finish. And if these are the same number, then you don't have a clear start and clear finish. So it starts at -3 until we get to 1. And then this increasing starts at 1 and ends at infinity. So remember, infinity always has parentheses first. And then in increasing and decreasing, there's always going to be parentheses. All right, so let's just use this as our example. You know, we're going to the top, and when we get to the top, you know, we're at the -3, we're not increasing or decreasing. We're kind of at a resting spot. So that means I'm not going to include -3 because at -3 I'm not increasing, I'm not decreasing, I'm resting. So we don't want to include -3. And the same idea there, all right? So let's talk about positive and negative now. So positive, we're talking about the interval where the function is above the x-axis. We're looking where all the y values, remember that's y, whoops, sorry, you can't see this, is bigger than 0. And then negative is going to be the area that's below the x-axis. So where all the y values are below 0. So again, I'm just going to go left to right. What's positive? What's negative? So starting, let me get my caps off here. Going left to right, you know, this is all the y values are negative. And in this little blip, all the y values are positive. Now all the y values are negative, and here all the y values are positive. And again, I'm just going to take all these important points. We would never just keep rewriting them. You're going to have one graph and just use it over and over again. So So we had negative infinity, we had negative 4, 0, negative 3, 2.5. Oh, you know what? I missed this one here. I didn't. Hello. So negative 1, 0. We said about 1, negative 2.5. Here is 2, 0, and here is infinity, infinity. So remember, you can always pause this video to write these down. All right, so again, I just like to work my way left to right. I don't necessarily do all the positive or all the negative. I do whichever one comes first. So if I look, I've got one negative set. Then I hit a positive set. Then I hit a negative set. And then I hit another positive set. So I'm going to start with the negative. So again, although I'm looking at the y's being positive versus negative, I want to use the x values to describe it. And I'm going to show you, this is the perfect example why we don't use the y values. So we're going to start here at this arrow, and going left to right, it starts at negative infinity, and it goes to negative 4. And then I'm going to switch to positive from negative 4 to negative 1. And then I have a negative stretch from negative 1 to 2. And then my last positive stretch of 2 to infinity. All right, let's talk about parentheses versus brackets. Again, almost all the time, this will always be parentheses. So first infinity is always going to have parentheses. But why do these numbers always have, usually, parentheses? So in this stretch here, you know, all my y values are negative. And then when I get to here, you know, 0, I'm looking at this y value, and it's not positive or negative. Again, it's kind of like just neutral. It stops being positive. It stops being negative. So I don't want to include 0. It's just, it's negative, 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 negative. Oh, now it's not negative or positive. So I don't include 0. Then it's positive, 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 positive. Gets here, it's not positive or negative. So we don't want to include those values. So let's talk about why we don't use the y's. And a good example is, let's just say, look at this negative stretch. So let's say you were doing the negative stretch. Where does it start? Where does it end? And you put 0, and then you put 0. Remember, this is supposed to be the smallest number, and this is supposed to be the biggest number. Well, one's not smaller or bigger than the other. This is supposed to be a starting point, and this is supposed to be an ending point. And if this were a race, I didn't even go anywhere. I started at 0, and I never went anywhere. So that's why we don't use the y values, because there's not a clear start and finish. And because y's can repeat in a function. So doesn't mean they will, but they can. So that's why we always use the x values. All right, the relative max. You want to look at the top of the hill, and for relative min, you want to look at the bottom of the valley. So the relative max, we're looking for the largest y over this interval. So I'm not going to rewrite all these points. I'm just going to write this. Again, remember, these were some estimated points here. And since the max refers to y, we're going to have to write it out as this. You do not write it as a coordinate. So there's a relative max of, and if you really want to get specific, you can say y equals 2.5. You can just say 2.5 because that does refer to the y. When x equals negative 3. You have to write this out. If you write the ordered pair, this is not correct. All right? Relative min. So here we're going to say there's a relative min. And I should say minimum, but you know,